Good morning.
Yeah. Yeah, I forgot.
Has anyone not picked up their exam from 2 weeks ago?
What's your name?
Miss, what's your name?
Warren.
Anyone else? He's working on those.
Warren.
I'll just go through the
Was this from Friday? Okay, I wasn't here.
Man, these masks messed up your peripheral vision. For those of you who just came in, does anyone still need their exam from 2 weeks ago?
Yes.
Did I miss anybody? Anybody else? Functional.
If you want to set up the camera, but
Yes.
I just had to rotate out of the way so people can get in. If we need to use the other room, can I use?
Yeah.
Okay, folks, it's about that time. Want to remind folks that we've got another one of those cool website or video posts and comment series coming up. So just so that doesn't pile on you, do be aware that we've got that coming up for next week. And maybe an early start certainly would not hurt. So for this activity, again, we'd like to break up into groups of 3. So what I think I'd like to have is the 3 of you work together as a group, the 2 of you work together, and the 3 of you, and the 2 of you, and the 3 of you, 3. Oh, let's see where you sit.
What's your last name?
Over here. Runger.
And
Thank you.
I don't have one for her. She wasn't here last
okay,
time.
go ahead. Okay, so I'll have you 3 work together. 3 and 2. In fact, I'm going to have the 2 of you work together. You work with the 2 folks here, 3, and then a group of 2. And as people come in, we'll have somebody either join you folks, or you back there, or you folks up here. So for the first activity, what I'd like you to do is, of course, like before, write your full name on the page. And for your group partners, if you could just list their first names, that's fine. And the first question is, will a electric current or electricity have any effect on a compass? And the answer is yes. I'm just going to spill the beans here and go with that being yes.
What's your last name,
So
sir?
you're going to skip items 1 and 2 on the first page and go straight to item 3, which is basically take the compass and pass it around. You want to find a place where you don't have a spurious magnetic field. And I will tell you, on these tables, right between, well, look for the posts where there's attached to the floor, the metal is virtually guaranteed to be magnetized. So you want to avoid the spaces where you have above where you have the posts. And also underneath, you can feel there's a metal bar right about here. So when you do your measurements, try to have the compasses as close to the southern edge of the table as possible to avoid the metal up here. And just to be sure, move your compass around to make sure without any sort of electricity going through your circuit. So without a circuit, make sure that you can find a region where you don't see the compass needle change its direction. Ideally, it should pointing somewhere over in this direction for north. So that's the first thing you want to do, is to kind of pass the compass around and have it so that everybody can find a region where you don't have any spurious magnetic fields that you can work with. What's your last name, sir?
Sam Hayes.
So go ahead and put down your names and your partners and pass around the compass. And then go ahead and start making observations once you do that.
Doing the same teams as before?
Basically, you're going to follow this spreadsheet. You're going to pass we're only going to do a couple of experiments today. So
We have a different person back.
that's fine. Different group, just write the names of the people in the group, that's all.
Thank you.
The groups today don't have to be the same as what you had on Friday. As long as you're in groups of at least three or two, at least two, preferably 2 or 3, it's fine.
Right. Dr. Steve, we got a question online
Okay,
What's your name?
from Jacob Berry. Wanted to make sure he was counted for attendance. Should he still be present since he'll have an appointment later to do this activity later?
Jacob, no, you don't.
Mine's
So thank you for filling out the forms. I think I've got it straightened out as to which Jacob is who. And I hope to be able to determine a time for that later on today. But no, you don't need to be here. Actually, if you could just tune out for about darn it, we are going to have some discussion after this activity. So if so you could maybe just have this on the background and hopefully avoid spoilers. But for the last 20 minutes of class, I do want to start going on to material that's not part of the activity. Does that make sense? You can go ahead and unmute Jacob, or just, yeah. Okay, great, thanks.
Yeah. We're just skipping those.
Who else is online?
Sierra Burmeister, Ivy Sackett, Kate Andrews. I don't think, he said we can skip. We had one more. Somebody-
Item 3.
Section 3.
Yeah, again, you want to start at section 3 on the first page.
So first check your environment for magnetic effects. I found this one online that is clear from spurious magnetic field.
Did you find, did you go right your
You
table?
need to borrow from the compass so that you can do this on yours.
You might find that it's, let's see, on these front tables. Now, the bar here is more like in the middle. So, just move it around. And,
I had parts come in first.
well, yeah, move it over here.
So I've got it's a World War II trench gun. That thing, which is awesome. But it's 70-something years old, so the springs are all worn
It
out.
looks like the best place is like right in here. So if you try to
But I've got
when you
spring
re-experiment,
to it, and it's
keep your
sweet
touches like
shooter.
right in this area. And here's bad, here's bad, here's bad.
Okay, we just have the one compass between us.
Yeah, between the two, we pass them back and forth.
What's your last name?
Castile. So does anything back to the compass?
Miss Castile, could I get you to join these 3 folks over here?
I was with them last week, so sure.
Do you want to grab this too?
Hey, Dr. Steve,
Yes.
if I can shift those people that are online into a breakout room so they don't hear or see us during the discussion, if you want to do that.
I'm not terribly concerned.
Never mind.
Did you get your exam from a couple weeks ago?
I did, yes. So Ethan, are you reading through?
Yes, I am. And I think I'm ready to set up on mine. So if you can name your compass, I will get ready. So, let's see here. Which of these ends is negative? I think it's this one. Is that, okay.
Yeah, warrant item 1 and 2, this was item 3.
So, question.
Yeah.
Do we just set it up like, we just set it up like this?
Okay, it's actually better to have, folks, when you set up your wire, it's best to have the wire right on top of the compass, not underneath, but on top. So, and it's best to kind of hold it.
Okay, so once I actually get things going, I'll hold it there.
Yeah, and so in here, it's kind of hard to hold the wire straight right over the compass and then flip a switch. So the best thing to do is to flip the switch and then move the wire to right on top of the compass and then move it away. So that's about the best procedure for this. And when you initially move it to right over the compass, when you first move it there, try to align it so it's along the compass needle. The deflection, as you'll see, is perpendicular to that.
Not quite perpendicular on mine, but, interesting.
Probably just like 5 times. Right, decent. Yeah.
We get a little bit of reflection on where you're going.
So they serve fried chicken.
Clockwise.
That's all.
No cakes, really
That's the weird part. So, Dr. Steve said it should be perpendicular to it, and I believe I have it in the spot where. Yeah, there's no magnetic interference here. I got it right there.
We're going home
And
for
once I connected, we get a deflection of about.
Well, it's not connected. I'd say connect it and then move the wire.
for like the telltale heart, sort of. Like the poking on the house this time around. One of the
I
rooms,
set it like this,
telltale
and
heart.
then
My
the
dad
wire
built
in
a
place, we
false
get a
floor
deflection of about
with a hole in it,
30 degrees.
so he can stuff a whole bunch of big body parts into it. And he wants it to glow like a heartbeat. So I've got parts coming in. We got some red LED tape and my MOSFET, so I can control them with an Arduino to give them a pulse.
Are you trying to get it?
No, we just do it for free. Yeah, just for fun. And terrorize small children, so it's enough payment for me.
Okay. Would either of you like to test this observation for yourself?
Well, I can see really well.
Let's see here, remind me your name. What I-
You know, there was one time, so before we did the haunted house, when I teach got a trip, I dressed up in all black. And I was sitting on our mound on the corner. So I was just standing there, and I would just watch people as they walked past. I would just turn my head slowly and walk them out, so just push people out. Most people thought I was like a mannequin.
Be sure to turn the wire
Pretty
around
amusing, but I
so
had
that
one
if
of
there
the
is a
girls
flow
that
of
called.
electricity
She
in one
put her
direction
hands
or
on her
another,
hips,
look to see if there's a difference in which
stopping up
direction.
to me, so I, of course, I
Depending on
jumped
whether or
in the
not
speaker, but I got her to
you have the wire going from the left of the battery
I
with the
don't even know if
compass
I did.
It was good.
in the direction of the north of the compass, or if it's the other way around. So
So you can do move on to move by
if you're not sure what I mean by checking,
now.
Sorry, say again.
changing the direction of the wire,
To move on.
let me know.
Yes, let's. Everybody satisfied? Especially
Yeah, all the light bulbs should be working. I tested all of them.
now, the tap switch open. So,
Unless it's an alligator clips, I didn't try all that.
carefully release.
No, so problem the last time wasn't so much that the lights didn't work.
Branch in the
They don't
opposite
work,
direction.
they all lit up, they were just doing weird things, resistance and such. And not lighting up the way they should have. So I still don't know why. Because I know all the light bulbs in each group are the same voltage. It's all, should be fine. Yeah, I have those same issues again though.
Be sure also to check for deflection of the compass before the light bulb and after the light bulb, or to the left side of the light bulb or the right side of the light bulb, whichever. Basically, look to see for differences in deflection at different points in the circuit. And then when you do this for 2 light bulbs, instead of looking in 2 places, you'll want to look in 3. Between the 2 light bulbs, between the battery, the first light bulb, and between the battery, the second light bulb and the battery.
From my observation.
And for each, look for, see if there's that direction. If there's any sort of indication of direction with the compass deflection. And then you want to repeat that for the third. So it's basically 3 sets of experiments, and I'd like you to hand the equipment to employees around so that everybody gets a chance to mess around with the wires for the different configurations.
Okay, again, does any, do either of you want to try this for yourself?
Well, the answer is they need to. So when you do the 2 light bulbs, somebody else does it, and then somebody, a third person, does it for the 3 light bulbs.
Okay. So my observation for this one was seeing amount of pins in the opposite direction.
And remember to do the hand sanitizer, because we are doing manipulatives today.
That's crazy.
So is there what?
That's your thing.
Yes.
Yep. Like 8 days till an election. No, I've requested an absentee ballot. I'm just waiting for it to arrive. Probably be here today or tomorrow.
I would ask you who you're voting for. You should probably do it.
Yeah. Imagine it here. Too much people. Yeah, no matter what you say.
Unless you're not on your list.
Yeah.
And then everybody else is just like,
Yeah. Yeah, I know. I think 2020 very cool. Yeah, it would.
Well, if I had it with
I didn't start nuclear war.
they're running negative and positives as south north. If I flipped it, so that
Blue.
positive to negative was north to south, it would then rotate in the opposite direction.
So negative is clockwise.
Negative is north to south to north, it makes it go clockwise. That's still negative. That's still the negative.
Not typically, no.
For it to be like that, it would be.
It's okay.
Yeah, the metal clips themselves could be magnetized, so you want to kind of avoid that. A way to check to see if your clip is magnetized is don't have any electricity going through the circuit at all. I have it disconnected. and bring the tip of the elevator clip near the compass. Right up through. Ah, look at that.
Okay, so whether you're ready for it.
Definitely magnetized.
Anytime it's a negative flow, it's possible, anything if it's a positive.
Yep, it looks like just about all the clips are magnetized. So when you do this, make sure that you're only using the middle of a section of wire, far from the metal clips.
Probably didn't work because the man. Anything metal fits back.
Yeah, the problematic locations are right near the post, and you can feel it in the table. You can feel the bar, the stamping, and it knows that that's in different places along different
You can
tables.
cut it down.
Yeah, that's where's the pressure point.
So you've tried to.
You just want to avoid where that bar is in general.
For gas, transfer of magnetic field. Around it, cancel it out, for example, be it in the bus, it's negative, two negative field.
Oh, no, my bad.
If you're not playing around with 2 light bulbs in the circuit right now, you probably want to speed up and get to that point.
So the amount of deflection for any wire, regardless of direction, is the same as the engine.
Okay, you want to avoid being near the clips again. And the way to test this, the best way, is to have a place where you just leave the compass and don't do
All right,
anything.
let's do the procedure
And
you
then
said for double checking. We're
do
not
that.
doing magnetic interference from the clips.
Yes. And then just move this around and then try. Right.
Okay, so we disable the circuit and then hold the compass near the wire clips, which shouldn't be a problem, honestly. I don't think we were holding it close enough to the clips to make a difference.
Yeah, I'm aware of that.
Sometimes you can get in.
If we hold one of those near the compass and we get the deflection, there may have been a little.
Again, the best procedure is to not move the compass at all, but move your setup around for it. And then move the wires over the compass needle.
Oh, it was right there.
So the battery and the light bulbs are actually pretty mobile.
Okay.
The best practice is to not move the compass. Just keep the compass on the same spot of your table and then move the apparatus around it.
Okay. Let's try the same thing with 3 lights.
All right, I think you're up, Riley.
Yeah, you can feel them. You get the pulse switch. And then your clock is now pointing on.
And the batteries may also be magnetized. So it's a deflection, but clearly smaller than what it was.
And then the same way.
You need another lamp.
I did the math, and we estimated about $300,000 just from the university, just from our university.
Then keep in mind.
Okay, I'm holding it along the.
Once you're finished with writing down the notes on page 20, you want to pause and we'll have some discussion.
Put the needle over the. It just helps it. us see
It helps
how-
us count how much deflection we have.
Like not insulate.
So
Yeah,
yeah.
it's,
About 30 degrees.
yeah, it's good.
I couldn't see how much.
I can't remember, they're a subsidiary of some major company.
Also 30 degrees. That's interesting. The amount of deflection, even though there's less electricity flowing through it, the deflection is the same as when we had just one light bulb.
I've heard that. Definitely.
Yeah, that seems kind of counterintuitive.
Okay, so
Perhaps we're getting some interference from the gator clips.
Possibly, so let's check this.
So when I did it,
Boom. Okay,
30 degrees.
and
That's the
then
same.
let's,
Are you ready?
No interference. Never.
Play the drums at all?
Okay.
No.
needs a bit more.
Could never get it down.
Well, a bit more initially, but it
Just
kind of
started
settled
clicking.
down in the same area.
I'm I'm great.
It goes up to like 50 and then drops down to 30 again.
It'd be fun.
With the full circuit, I think it went from 30 to stay there.
It'd be a good way for me to learn my users.
So. I got
And they're
Uh,
playing
no.
drums at like midnight, which is a
That's
really
looking
good
more like
idea.
it.
I thought, if I just play it light,
Where's the
people
20?
can't hear
So
it.
yeah, it's less.
A little less.
You gotta be careful in these observations. Sometimes the difference between what you'll see on the compass between 1, 2, and 3 light bulbs is only maybe 5 degrees of deflection. So you wanna be careful in your observation.
My roommates, or not my roommates, my neighbors seem to prefer to play.
If you're not playing around with their 3 light bulbs in your circuit at this point, you want to probably get there
The
soon.
games themselves are quiet, their reactions to the video games are not. There's a lot of let's go at the top of the phone. Yeah. Yeah, or,
You live in an apartment.
yeah, I'm on Bridgecrest.
Okay, so
Luckily, I'm on the farthest side of the apartment.
it always flows.
Complex.
It flows in the same direction throughout the circuit. It obviously doesn't change directions from one point to another. However, it doesn't really tell us what specific direction it's going, whether it's positive, negative, or vice versa. So it indicates a difference in direction. I agree. Yeah.
That is cool. Now, we're at Bridgecrest, so we're very top of Red Hill.
How do you like that?
It's not bad. It's a nice apartment complex and it's cheap. So that's good.
Okay.
But yeah, my neighbors are a bit annoying. Rather annoying. And it's a bit of a walk from the top of the hill down. And from here back up the top of the drive. You know, this road out here is public. So we can park from the street. You don't have to have a general pass or anything.
So it also asks, does the compass ever seem to indicate the amount of electricity is significantly less in one circuit than another? And I'd say no, not really. The deflection was the same no matter which way we tried to that.
Well, wasn't one 30 degrees and one 30 degrees? So was that-
Across different circuits, yes, but in the same circuit, trying to different parts of the component, we get the same deflection. So with the 3 light bulb circuit, we get about 25 degrees everywhere. With the single light bulb circuit, we get about 30 degrees everywhere. Does that make sense? And I'd encourage you to go back and check this for yourself at some point. Do you guys agree with those observations?
Yeah, so he was doing a different degree because it was smaller. What you're saying. Well, it's just because like, for the amount of electricity you have to give up the
So, yeah, I changed my light bulb.
Mhm.
And I put it in LED light bulb.
Mhm.
I left one of the other light bulbs in there, so I was like, oh, this is so bad.
Yeah.
It's like, and then on the other side, it's like ambient orange.
Okay, folks, you wanna finish up page 20 here soon.
Okay, I'm I'm done on page 20. Are you guys done as well? Okay, tell me when you're ready.
If you're done with page 20, go ahead and read the next activity, at least think about it. This is not an activity we're actually going to do, but I do want you familiar with it. And at some point, actually, no, just we'll stop at that.
So just take a moment to consider, but don't actually do anything.
Right. So once you're done filling out page 20, go ahead and read page 21, and then hopefully we'll have some discussion here. Step 4 for reference. You were to have finished that. But
I had, like, I did all that.
oh, yeah, go ahead.
I think you said to read through it, but.
If you've got it. Okay, folks, I think I'd like to pause this and go on to some discussion, but first kind of summarize what people saw. Clearly, there was a deflection of the compass needle. I think everybody, every group saw that. And did you see a difference in any one circuit for the amount of deflection of the compass from, say, if you had one battery, one light bulb, whether or not you had the same deflection before and after that light bulb? Did anybody see a difference in the deflection before and after a light bulb? Frankly, in any circuit. Okay, it's from what I was hearing, everybody was pretty much seeing the same deflection of the compass before and after each light bulb. In fact, everywhere throughout the circuit for any given circuit. And that in general, folks saw more deflection with just one light bulb in the circuit and the least deflection of the compass when you had 3 light bulbs in the circuit. And it might have been only a few degrees, but it was at least noticeable. Does that kind of match people's expectations or our experience?
We had one counterclockwise and the rest not. Do we have it set up wrong?
Well, how did you have the wire? Because if you have, say for example, I'm just going to do this, illustrate it. If you have, say, this going to the battery over here, you should expect a deflection in one direction like this. And if you turn it around and do it like this, you should see the opposite deflection. So whether you get clockwise or counterclockwise depends on the orientation of the wire. In that if you always went, say, from the battery towards a bulb or a, if you went basically had your circuit laid out and you only looked at it, the compass needle, the north pointing, say, in clockwise, it was good. But if you change the direction of the circuit say doing a loop, it would then change it. So, and that's what I was asking everybody to do, is to, for each point in each wire, look at the current when it's going like this, and then like that. And you should see an opposite deflection. So that clearly implies that there is a direction to electricity, yes? We saw either deflection clockwise or counterclockwise. It was very, very consistent. But does that tell us actually which direction it's going?
Not really.
No, logically it doesn't. It tells you that there is directionality to electricity, what we call electric current, but we still have yet to find any experiment that could tell us which direction it's going. Because it does not seem to diminish at different points in the circuit. The amount of electricity, or what we call electric current, seems to be the same everywhere in a circuit for that specific circuit. The amount of electricity or the electric current is different for different circuits, but the same everywhere in any given circuit. We just don't know which direction. And it seems like the more light bulbs we have, the less electricity we have, the less electric current. Does that seem to match expectations? So electricity, whatever it is, does not seem to be consumed by light bulbs. It determines how much is present, but it does not take it away when it's there. Is that kind of making sense? Okay, now with the next activity, this is time consuming. The question is, we're going to drain batteries if we leave something set up long enough. The question is, what will drain batteries the fastest? And of the possible situations where we either have no light bulbs, basically a battery to battery, or one light bulb in the circuit, two light bulbs in the circuit, 3 or 4, no, well, just stop with 3. Which of those do you think will drain the battery first? Any thoughts? Sir, in the back?
Well, based on what you just said, where you said no electricity is consumed, it would just isn't it?
What'd you say that again?
You just said that no electricity is being consumed and we have more batteries. So they're just cycling.
That's not saying that the batteries won't run down. It takes energy to make that electricity, and that energy has to come to the batteries. So logically, the batteries will have to run down. But if you look at the circuit, basically the battery is giving up its energy to produce that current. And if you look at the current that goes through a circuit, it is not diminished after the current flows through a light bulb. That's what we were coming up with. That's not the same thing as saying that the batteries aren't going to drain. You know from your own experience that batteries don't last forever, right? So which of these circuits, oh, sorry, what's your name?
Dylan?
Okay. So does anyone want to comment on which of these circuits would drain faster? Anyone?
I think the one with 3 bulbs would drain fast.
Okay. What's your name, miss?
Crystal?
Crystal. What?
C.
Okay. How do you spell that?
SCHIE.
Okay, I see it. Sorry. Not what I was expecting. Ma'am?
Wouldn't they all be the same? Because the same amount of power is being exerted? Because when we do all light bulbs, each one we add, the light gets dimmer and dimmer.
Okay, but yeah, that's an interesting point. The question is the total amount of light produced different? Is the total amount of light, the total number of lumens, how bright is it with, say, just the 1 light bulb versus, say, 3 light bulbs? The 3 light bulbs are obviously individually dimmer, but is the total amount of light they produce less than or greater than when we just had 1 light bulb connected? I've got a pretty firm opinion. Sir?
I would say it'd be the same.
It looks the same? So if we were trying to light up the room, in fact, that might be worth trying. Could someone rig up their circuit to have all 3 light bulbs connected and then just 1 light bulb? So why don't you go over here? I'm going to direct you guys. It looks like it's connect that up so all 3 light bulbs are lit. Maybe you should connect that up so that only one light bulb is lit. So do that quickly, please, and have them on like right now. Guys, close doors and turn off lights.
I got all three of ours.
Okay, go ahead. They got theirs set up, so don't worry about it. Okay, so. Okay, so disconnect your light bulb with just the one. Okay, see how much the room is illuminated. Look around and see what you can see. Okay, connect yours up again. Okay, now disconnect it with the 3 light bulbs. Disconnect it. Just take away one of the wires. Okay, what do you think? Which produces the more total light? The 1 light bulb or the 3 light bulbs? The 1, it's very, very clear. Lights, please. So, more energy is obviously being expended with just 1 light bulb. But that is not what drains the battery the quickest.
We have another suggestion.
What's the other suggestion?
Is it because there's only one source that it's going to, it's not spread out between the 3? Is that why that's brighter?
Not quite. That's not quite what's going on. But I still haven't heard somebody tell me correctly which of the 4 arrangements possible. No light bulbs, 1 light bulb, 2 or 3 light bulbs drains batteries the quickest. I've yet to hear anybody comment on what actually happens. Sir?
I would say the one with no light bulbs would drain the quickest. We observed the least deflection in the circuits with the most light bulbs, which would logically suggest that there is the least electricity flow in them. And so that would mean the one with the fewest light bulbs, none of them would have the electricity flowing the fastest and leaving the charge.
That is correct. You find the most deflection if you have no light bulbs connected whatsoever. If you just connect the battery terminals, you'll see a very large deflection, and the batteries get very hot very quickly. You've shorted them out. Anyone that's played around with electrical devices powered by batteries, you know that if you short out the battery, it's drained very, very quickly. Does this match experience? It should. When I was young and I had a screwdriver, at the age of 3, nothing in the house was safe. I was taking everything apart to look inside. I was constantly playing around with things. One thing that got a lot of notice in my family is I was able to repair a toy of an older cousin because I took it apart and found where there was a broken circuit. So I encourage this sort of behavior in children, taking things apart, being inquisitive, because this is how you learn things. So the fastest draining is when there's no light bulbs whatsoever. And then, believe it or not, if you hook up 3 light bulbs and see how long it'll take before the batteries to drain, it will take days to drain the batteries when you have 3 light bulbs, but it will only be about 6 to 8 hours for 1 light bulb. Because you're drawing more energy out of those light bulbs, and the energy dissipated seems to be related to this electrical current, what we were measuring with the deflection of the compass needle. So that's the takeaway from this. In that by adding more light bulbs, we're adding what we call more resistance. So that's electrical resistance we're talking about. The batteries provide a certain amount of oomph behind this, and we call that voltage. Voltage is like a force on the electricity, along the electric current. How much current actually flows depends on not just the voltage, but how much resistance there is to this. And this is all summed up in a couple of relations. The first one we call Ohm's law. In that the voltage, basically the number of batteries you have, will equal the electricity, the current measured in amps, times electrical resistance, which is measured in ohms. So basically, you can think of each of these light bulbs as being a resistor. And it's in these resistors that energy is dissipated. Energy is given off in the form of, well, most of it's going off in the form of heat for these light bulbs, but then there's a measurable amount of energy given off in the form of light. But most of the energy that's lost in these bulbs is by the heat they produce. Now, energy loss does not mean current loss. How much current actually flows is the same everywhere throughout the circuit. But the power is lost in individual elements of that circuit. How much power is lost is given by the current times the voltage. And using Ohm's law, we can eliminate voltage and put in I times R here to get that the power goes as I squared R. Or we can eliminate the current and write it as V over R to get that the power loss is also the voltage squared divided by the resistance. These are all equivalent, just in terms of different variables. So you can see that we lose more power with more current, more voltage, and with more, with less resistance, we lose more power. So the least resistance you have means the more current you have flowing. And the power loss roughly goes to the square of the current. That's the most important thing. By doubling the voltage, you'll double the power loss, but by doubling the current, you quadruple the power loss. That's kind of the lesson here. Let's go with the PowerPoint slides. Now, what I'm going to ask you to do is to hand these in, and I'll do that. I'll basically look over what you wrote down, record scores, and then I'll have these back on Wednesday for you to pick up. So hopefully we'll have, basically I want you to have these guys back. So go ahead and take the first handout, the one from Friday, home with you, and use that as your notes to prepare for the exam. And I'd also like you to have the second sheet of notes available for you to study for the exam, but I need them turned in at the end of class. But I do encourage you, like with the regular exams, to be able to pick those up. Well, let's consider this question. So we've got a light bulb connected to a battery. You've done this setup, something similar. But what if one of the wires is connected to a pipe? Will the light bulb light? Yes or no? So real fast, get your cards out. A for yes, B for no. Get them ready. Okay, show me your card. A for yes, B for no. Okay, do we have anybody on chat?
A, 1A.
Okay. Could I get a volunteer to defend why A is correct? Ma'am, what's your name?
Riley Castillo.
Okay. Please.
Even though it's connected to the pipe, there's still a circuit being made connecting the bulb to the battery.
Okay. Could I get a volunteer to defend B? Mr. Crossgrove?
I think the electricity is going to take the least resistance, which is going to be straight to ground. So it's not going to complete its circuit back to itself, but instead short itself out through the pipe to the ground.
Okay. I'm thinking I'm not going to have discussion here. Basically, what you described, Mr. Crossgrove, is correct if we had, say, a plugging into a wall, but not with a battery. In fact, I'd encourage you right now, if you've got the battery packs nearby, hook up one light bulb and then connect one of those wires basically to the metal frame of your table, and to see if that has any effect on it whatsoever. The ultimate authority is always the laboratory, is always experiment. But basically, the battery, one terminal, wants to get rid of a lot of extra electrons because of a chemical reaction. The other terminal wants to suck in electrons in order for a chemical reaction to proceed. Current flows is you can get electrons from one terminal to end up to go to the other terminal. And you're not going to stop that by grounding the circuit if it's connected to batteries. It should have no effect whatsoever. So the light bulb will, in fact, turn on. Let's go ahead and go to the next slide. Okay, we kind of already answered this. One light bulb connected to battery, then two bulbs connected in series to the same battery. For the circuit with two bulbs, the battery puts out, well, this is deflection of the compass needle. It puts out less current. So A is the correct answer here. Less current means less deflection of the compass needle. Let's go to the next question. Now, which produces the most light? We just demonstrated this. The single light bulb produces more light because you have more power. The way to think about that is, again, power is the brightness. It's watts, it's joules per second. If we double the resistance for the same voltage across our circuit, we get less power. That's what's going on. Or you can think of there as being the current times the voltage. We end up having less current with two light bulbs as opposed to one. And if we square something smaller, we're certainly going to get less power. That's about all the time we have. Thank you for your attention. Please turn in your second worksheet when you completed today, and I'll have those available for pickup tomorrow.
So you just send them over here?
Yeah, anywhere. But the one from Friday, I'd like you to keep for your notes.